Hello Math Tutor TSI students, this is Miss Wiesman and today we're going to look at exponent rules. When you have exponents, remember an exponent is on what's known as a base, and for example, like if we look at this situation right here, the bases are the A's here, okay? And then your exponents are like the M and the N. So if we start looking at that situation, if you have the same base, remember that when you're multiplying like bases, you add their exponents. So that's why they're saying that since they both have base A, you add M plus N to get your answer there, okay, if you're simplifying. So when you're multiplying things with exponents, you add their exponents, okay, if they have the same base. In opposite, if you're dividing things that have the same base, so for example, with bases A here and here, now we're dividing, then you subtract your exponents. So that's why they're saying we're going to subtract M and N in a specific way. Also on this one, it's very similar. It's just set up in a different way because of the fact that they're saying that the larger piece is now in the denominator. So we'll look at that in a second and we'll see how that works, okay? If you have an exponent raised to a second exponent, so notice how we have our base A, and then we have it raised to M, and then it's also raised to N. When it's raised to both exponents, you multiply the two exponents to simplify the situation. If you have two pieces as different bases, like so we have A and B now as bases here, with the exponent of M on the outside of the parentheses, then it's kind of like you distribute it out to each piece. You put that exponent, you apply it to each base, okay? So that's why they're saying M is now on each piece, on A and B individually. And also you can apply that same type of situation to a fraction. So like if I have my two different bases A and B here inside the fraction and then they're raised to this exponent M, you can apply that M to each of those pieces so that now you have M on A and you have M on B. Okay, so we're going to go through each of those different types of situations today and we're going to add a couple different rules once we get to another part. So on number one, we just want to simplify these two. The important thing is they have the same base x, and so I'm going to add the exponents. So if I add 4 plus 3, I get 7, and that's our answer. On number two, I have two different bases with different exponents. So I'm going to put a 1 on this b right here. There's always automatically a 1 there if you don't see something there, okay? And so we have a, and I'm going to add the exponents. 3 plus 5 is 8, and then we have b, and we have 6 and 1, which makes 7. Okay, next on number 3. Now we have some numbers, so we deal with those first. 3 times 4 is 12. And then we have an n, m to the 1 and an m to the 1. So 1 plus 1 is 2. So we have m to the 2, or m squared. And then we have a 4 and a 2, which makes 6 when you add them. Okay, now we're moving on to division. So what I like to do with division is I actually like to note to myself where is the larger a or x or whatever as an exponent. So for example, 6 is bigger than 4. So my larger a is in the numerator because that's going to help me. That means that I'm going to place a in the numerator automatically, and then I'm going to subtract my exponents. So 6 minus 4 is 2. Now, some people put a 1 here to hold its spot, but technically, since it's a squared over 1, we can just say, oh, it's a squared, and that's our answer. If we look at number 5, our larger n, the 8 is in the denominator, so I'm going to go ahead and put n in the denominator, and then I'm going to subtract them. 8 minus 4 is 4. Now, I do need a 1 here to hold its place because it doesn't make sense to us in the math world if we don't have a numerator. Okay, so then on number 6, I'm starting to have x's and y's. Since there's only one type of x, I'm going to leave the x squared where it is. the larger y is in the numerator, so the y is going to go in the numerator, and 5 minus 3 is 2. So you could put a 1 below this, or technically we can drop it and just say x squared, y squared. Okay, on number 7, my larger x is in the denominator, so I'm going to place it downstairs, and then 8 minus 7 is 1, so we can put that there, or technically you can drop it because x to the 1 is just x, okay? And then really both of these are y to the 1, so what happens is 1 minus 1 is 0, so our y entirely cancels itself out, so we can just leave it. And so I do need something to hold the spot here as a 1. Or you can think of y to the 0 equals 1. So that's why we're going to have a 1 up there, if that makes sense. We're going to look at that in a second. Okay, so number 8, I'm going to divide my numbers first out front, or reduce them. So I could reduce both 3 and 9 by a negative 3 there, because they both are negatives. So if I do that, I get 1/3. So I'm going to drop my 1, because technically we don't need it out front. Okay, and then my larger a is in the numerator, 6 minus 4 is 2. My larger b is in the denominator, 9 minus 3 is 6. Okay, next we're applying a second exponent to things that already have an exponent. So remember, you multiply those. So a, 6 times 2 is 12. On number 10, I'm going to apply the 3 to each piece here, since I have more than one piece now. So it's like saying I have 2 to the third and n to the third. 2 to the third means 2 times 2 times 2, which equals 8. So I have 8n to the third, or 8n cubed. Okay, next I'm going to apply the 2 to each piece. So 4 squared is 16. And then since my x has an exponent on it, 3 times 2 is 6, so x to the 6. Number 12, I'm going to apply it to each piece in the numerator and denominator. So x squared, there's already a 2 there, so 2 times 3 is 6, so now I have x to the 6. And then I have 2 cubed, which 2 times 2 times 2 is 8, so I'm going to go ahead and put an 8 there, okay? All right, the next couple of things we're going to look at is the fact that if you have a 0 exponent, then that really means that actual like base equals 1. So for example, 4 to the 0 equals 1, or y to the 0 equals 1. Okay. Or if you have a negative exponent at some point, that means it's in the wrong spot and you need to move it. So for example, on 13, notice how I have a negative exponent on that x. It's x to the negative 3. So I also like to kind of circle these so that I can keep track of that and say to myself, hey, since it's in the denominator, I need to move it into the numerator. When I move it into the numerator, then what happens is my negative exponent becomes a positive. So now I have x cubed over 1 technically as a placeholder, but we don't need that 1, so we could just say x cubed. Now, if my w has a negative 3 on it here and it's in the numerator, I like to put the 1 below it so that I can see what's going on. And then I say to myself, hey, it's in the wrong spot because it has a negative exponent on it. So since it's in the numerator, the w is going to move into the denominator and have a positive 3 on it now. And we do need a placeholder for the numerator, so we need a 1 there. On number 15, these two both have negative exponents on them, so one's going to go down here and one's going to go up here. So I'm going to have w to the positive 3 and I'm going to have v to the positive 2 up here. Okay, on number 16, so there's no denominator. It might be helpful to see it. That way I can say, oh, this negative 4 as an exponent means this needs to move. So I'm going to say that a is now to the positive 4 in the denominator, and then b to the 0, remember, equals 1. So really we're just going to say 1 up there and we're good. On number 17, I have numbers out front. I can't do anything with them, so I'm going to leave it as 7/3. A is there and a w is there, and I can't do anything with those. But I do have a negative 2 on that b, so I'm going to move the b to the denominator and put a positive 2 on it. Okay, number 18. I can divide a 40 by 20 and you get 2, so I'm going to put 2 here. I'm going to move the negatives around first. So I'm going to move this one down and this one up. And then same thing here. I'm going to move this one down and this one up, okay? So that now I have, let me look at my page since I covered it up now. I have a to the 5 and then I have a to the 1 down here and I have b to the 9 up here and I have b to the 7. That way I can say I also have more than one that has a base of a, so my larger a is in the numerator, so I'm going to leave the 2 here, and then 5 minus 1 is 4, so a to the 4th. And then my larger b is in the numerator, so b is going to be up here, and 9 minus 7 is 2, so I'm going to have 2 there. So I could put a 1 down here, but I don't really need it in the denominator. Okay, last two problems. These two are multiple choice, so it makes it a little easier on us. If they said that we're multiplying these two, I could go ahead and look at the 3 times negative 4 and say, oh, hold on a second. I'm going to go ahead and actually just write this down first. Sorry about that. And then I'm going to go ahead and deal with that. Okay. So notice how I have negative exponents. So because of that, I'm going to move these around first. Okay. So really these are over ones, right? So my 3 does not have a negative exponent, so it stays. My m has a negative 2, so it becomes a positive 2 if we move it down. N to the 4th, because that's okay where it is. And then we're multiplying it times my negative 4 is good where it is, my m to the 6th is good, and then we need n to the 7th down in the denominator. Okay, so if we multiply 3 times negative 4, we get negative 12, and notice how that would still be in the numerator. So that's a clue that we could get rid of these two, right? And then next, out of these two, notice how my larger m is in the numerator. So I'm going to put m in the numerator. 6 minus 2 is 4, so I should have 4 in the numerator. So already I can tell that a is going to be our answer. And then my larger n is in the denominator. 7 minus 4 is 3, so that's perfect. That's exactly what we had up there on a. Okay, and then last one, if they tell us the area of a rectangle is something and we know the length, that's a clue that you need to work backwards to find your width. Area formula is length times width. We know our area is 36a to the 4th, b to the 8th, c to the 6th. So we can plug that in for the area, and then we can plug in our length. 4ab squared, c to the 4th times our width. And from there, what we can do is work backwards to get our width alone. Since these two are being multiplied here, opposite of multiplication is division. So I'm going to divide both sides by this. Okay, that way now I just have my width alone. So if we divide 36 by 4, we get 9. So I know it's going to be either C or D. And then from there, my larger a is in the numerator. 4 minus 1 is 3. My larger b is in the numerator. 8 minus 2 is 6. And my larger c is in the numerator. 6 minus 4 is 2. So it looks like that is going to be answer choice C. All right, guys, I hope you have a great day. Let me know if you have any questions. Thanks.